In this video, we are going to solve how to find the starting point of a cycle in a linked list. This is an extension of the previous question where we found whether a cycle is present or not. I have linked that video in the description. You can go and watch that. Let's see this question. In this question, there is a linked list and there is a cycle, and we have to find the starting point. The starting point in this example is 2. So, we have to find the node from where the cycle is beginning. Let's quickly recap the methods that we used in cycle detection. The first method is we will go one by one and we will add the elements to the set. If it is already present in the set, the cycle is there. For example, if you see, we will add 3, 2, 0, 4 to the set. When we visit 2 again, it means the cycle is there. We can use the same approach in this one as well. The first node which is already present in set is the starting point of the cycle. In this case, it is 2. So, the time complexity is O of n, the space complexity is O of n. Let us quickly write code for this, and we will spend most of our time on the second method, which involves more logic and which is important. Let us create a variable current and loop over the linked list till the current is not equal to null. If set contains current, it means that is the first element which is present, and let us return that. That is the starting of the cycle. Otherwise, add to the set and move to the next pointer. If we reach this line, it means there is no cycle. We will return null. Let us run this code and see. As you can see, all the test cases are passing. Let us come back to the second method. In the second method, what we did is we created two variables, fast and slow, which starts with head, and we moved fast 2 pointers and slow only 1 pointer, like this. If they meet, there is a cycle. If they do not meet and fast reaches null, there is no cycle. In this method, we can't directly say that they meet at the starting point of the cycle. For example, if we have a linked list like this, the fast and slow can meet somewhere here. Let us see some maths and how to use the distances to get to the starting point. Let us say you have a cycle like this and fast and slow met at this point. Let us see the distance. Assume this is A from head to the start and length of cycle is C and distance from here to here is B. We need to find A. Let us say distance moved by slow. It is A plus, because they all definitely have to go from head to the starting point and then they looped some cycles and finally ended up at B. It is A plus, let us say slow moved x cycles, x into C is the length of the cycle and it ended up at C minus B. This is C minus B. Let us say distance by fast. It is also A plus, as it has to move from starting to cycle beginning, and it moved y cycles and it ended up C minus B. As we moved fast 2 times faster than slow, the distance by fast should be twice as distance by slow, which means A plus y c plus C minus B equal to 2 into A plus x c plus C minus B. or we can write it as a plus y minus 1 c minus b equal to 2a plus 2x plus 2c minus 2b. If we move all the a's to LHS and all the other things to RHS, it will become a equal to y minus 1 minus 2x minus 2 into c plus b, or we can write everything as some k. Then a becomes k into c plus b. It means when you start from this point, it loops for k times, and when you move another b, it reaches the starting point of the cycle. But how do you know k? We don't know k. As we don't know k, what we can do is we can start a new variable temp from starting head and fast from here, and let us say it loops k times. It will still be here and this will be here, and when it moves b and this also moves b, they both reach the starting point. In other words, when you start a new pointer from beginning and loop the same fast from here, if you check the place where they both meet, that is the starting point of the cycle. Once we find where fast and slow are meeting, start a new pointer from the beginning, move fast 1, temp 1, and when they meet, that is the starting. This is complicated to understand and difficult to get if you do not know the logic as well, but when you are preparing for interviews, you are expected to know this. The code is very simple. Let us see the code for this. Let us write the previous cycle detection algorithm using fast and slow pointer, and once we identify the place where fast and slow are meeting, then we can write the code that is specific for this detection of the starting point of the cycle. We need slow and fast, which start at head, and while fast is not equal to null and fast start next is not equal to null, we move fast 2 pointers, slow 1 pointer. If they are meeting, let us break it instead of returning anything. We will see what to do later. After this, if the code reaches this point, there are two possibilities: either the fast is equal to slow or fast at next equal to null. If fast is null or fast at next is null, it means there is no cycle. Let us return null. Otherwise, let us have two variables, one which starts with head and another one which starts with the fast pointer. As we know that there is a cycle, they definitely meet at the same point. Until they both meet, move both of them 1 pointer. And return one of them, as both of them will be same. As you can see, all the test cases are passing. This is one of the concepts to understand for an interview. In case you like this video, please do subscribe and check other videos on this channel. Thanks for watching and happy coding.